Hi, I'm Rohit. So I have made a console version of the Minesweeper game. So this is a devlog about that. So regarding the game, we'll just try the game out first, and I'll explain how the game works. From there, we'll move on to how I have implemented the logic. Right. So you have three difficulty levels. So depending upon what you have chosen, like if I go for two, there is like 15 cross 15, right? And for now we'll just go for the easy one. So this is 9 cross 9, and I just have to select a cell. So all these squares represent a cell, and each cell contains either a mine or like a score, right? And so she will start with you have two options when you select a cell. You can either I'll zoom it in. So you have two options when you select a cell. You can either open it, or you can open it or you can like flag or unflag it. So now I'll open it. So what I've done here is basically the objective is to open all the cells, right? And you must not open the ones that contain uh, a mine, right? And so how will we do that? So I'll just open another one. So see, I have at one, right? So the first row and first column, so this one I have opened. This turned out to be a mine, so that the game is over, right? And the main objective is to open up all the cells but the mines, right? And let's try this again. So this one, let's try this. Okay, I'm unlucky again, I guess. Maybe I'm not too good to the game. So I'll try it out again. So some kind of other case, right? It's the same thing. And okay, see, uh, so there are, you can see three types of values here. So there's zero, there's one, two, and three, right? So zero, like if cell is opened and it displays a score, so it shows how many mines are surrounding it. So this says two, right? So there are two mines surrounding, uh, these nine, like surrounding this cell. So these nine squares contain two mines at least, right? Two mines exactly, right? And so this three means there are three mines in these nine cells. So by that by this three we know that since these are not mines, these three are definitely mines. So that's how we can like conclude that these three are mines, and we can either like avoid clicking them, or you can mark them as mines, right? So I'll mark them as like I'll flag it. So depending upon the number of mines, you will get the number of flags. So I have set a kind of counter on that. So you can't place more than the like flags that you have, right? So if there are 10 mines in the game, then you will only get 10 flags. And yeah, so the same thing. So you'll repeat this stuff, and let me show. So this is mine, and see these three are mine. So I'll just open this one, so we can see that those three. So third row and second column is a mine, right? So I can see, as you can see, that these three are mine. So that's how the game works. You just have to look at the numbers and figure out where the mines are, and uh, not not open those cells, right? So the way I approach this is basically I've created a board, right? And these are the rules. These are the rules of the game. So you have a board size, right? And you'll take two integers. So the user has to uh, give a kind of input. So in my case, I have taken x and y input. So the row and the column, and like basically he gets to choose whether he wants to open the mine, or like open the cell or mark the cell, right? And he can also unmark the cell. So that's that. And one thing about this is the first input given by the user should not contain a main, right? So if this is a, like say a person is playing the game for the first time and he clicks like opens a cell and it turns out to be a mine, so is it's game over already. So instead of that, we'll just give him a chance, like chance to like the opening mine shouldn't be a mine, right? And the game should run until either player loses the game or wins the game. So the player loses the game when he opens up a mine, and he wins the game when all the other cells are opened up, right? So I have created a board of cells, right? And yeah, basically I set up the mines first, and then I for the surrounding cells I like set the scores. And once that is done, I'll like, depending upon the user of the input, the cells are opened, and if the cell opened is a mine, then the game is over. So that's it. uh, let's just go to the basic like blueprint of the game, right? The game dev, right? So first operation is to get the user input. So we all like I had said here, the first input shouldn't be a mine, right? So first we'll get the input, and we will open that, like we will get the input, and like depending upon that input we'll set up the mines. So we just have to avoid that particular input and place the mines, right? So I'll get the user input, right? And this operation will occur again and again, but the first time is special because only after that we'll be going on to board generation. So board generation is what, planting the mines first and then setting the scores, right? So that this board generation consists of two parts, right? Planting the mines and setting scores. And like once that is done, we can like move on to getting user input again and again, right? Because we now have the board set up, we can get user input frequently, right? And so opening of zero score cell, so this is special. The thing is, when, as I had shown here, right, we had opened the third row first column. So let me see, no, not this one. Yeah, we had opened the first row first column, so we had opened this one. This one turned out to be a zero, right? So basically when zero is opened, we have to open all the surrounding cells, right? If zero is here, we have to open all the surrounding 9 cells. And since this cell turned out to be another zero, we have to open all the 9 cells surrounding this zero, right? The same goes for, so in some cases you will have big gaps opening up. So let me try to get it. We get it in, it's usually at the like corners, yeah, right. So this is like totally random, but from what I have played, usually the corners it's much more frequent, right? So you can see that this kind of gap opened up, right? So you have a whole bunch of numbers, whole bunch of cells opening up with just one input. So the thing here is, when you open a cell with zero, you have to open the adjacent cells, and if that those adjacent cells containing zero, then you have to open uh, their like the continuous adjacent cells, right? So that is what is happening here. You can see 0 0 0 0 0 0, right? So it ended when there is no adjacent zeros. So that's what is happening. So with this, like, it can provide you clues. So 1 1 1 1 1 means this one is definitely mine. So the tricky thing here is to open like open up the gap. So that's a special thing. And lastly, we'll check for win or lose condition, and the flag counter part, it's pretty minute part, right? And yeah, so regarding the cells, uh, I made a small description, like say we are opening up the cell 1 1, right? So x and y 1. So if it's 0, then we have to open up uh, like the top left, top right. So I have made a small reference for the x and y coordinates, right? This x and y coordinates we have to check, and if it's 0, then we have to open those cells, right? So let's just move on to my code base. So yeah, so this is my code base. So I have a header file, and this is my main file. So these are my implementation for the different classes, and this is utility file, right? So we'll start with the header. Yeah, so just this is the main function, and yeah, so the header, I have made use of some macros for the difficulty size. So I have defined uh, three types of difficulty. So if I want to change it, I can just like change the size of the board here, right here. So I'll just change 9 to 5 or something like 30 or something. So it would just dynamically change it in game, right? And so that's one of the features that I've implemented. Same goes for mines, right? And so these are the utility functions. So I am uh, actually like storing the cells contain scores, right? They contain scores, and they also contain what stars. So stars meaning like, right here they contain scores. uh, that's it. Okay, never mind. I'll just open up third one, 9. Yeah, so they contain stars and scores, right? So scores are integers, stars is a character. So I've just made it all to contain character when they are displaying, right? So for that, I have set up a simple character in function and into char function. So I'll be able to access that data and change the data, right? So this is a random number generator so that I can place the mines accordingly, right? And so these are some of the enums that I'm using. So game state. So this represents what the current state of the game is. So playing one lost. So uh, depending upon what you have clicked, uh, either won or lost will be like set up. If you have won, I will have lost, and when that game state changes, the game will get like over, right? So next one is the difficulty. So this is like for reading purposes, right? For easily understanding. So we'll be looking at where you have used it, and player move. So player can either open or mark the cell, and status. So this status of the cell. So if it is logged, I will be doing some kind of printing, and if it's unlocked, then I'll be printing the data inside it. And if it's flagged, I'll be printing F. So we'll be looking at that later. And the content, it's this is for checking if the cell contains a bomb. So if it contains a bomb, then like if the player is opening it up, then the game state will be set to last, right? So he shouldn't open up a bomb. So that's why I've used the content enum. And yeah, we come to the cell class. So the cell class is what like I represent each cell, right? So these are all cells, and each cell contains a character contains a status and a content. So status is basically if it's locked or unlocked, and if it's flagged, and content is if it's a number or a bomb. So it has what constructor. So we just look at the implementation right here. So this is the constructor, and I have set the data as a character, right, and status as well. So all the cells are locked at the start, and the content is number. So by default, and display cell is basically when I'm printing out the board, right? So I have to print the data inside the cell. So if it's logged, I'll be printing nothing. And if it's unlocked, I'll print the data inside it. And if it's flagged, I'll print F. So that's the three cases. And then like yeah, let's go to set bomb. So set bomb is basically I'll set the content to bomb and set the data character to star. So when I'm generating the board, I'll have to set bombs for some random cells. So I'll use this set bomb function to set those cells, right? And increase value is basically if the if the current cell is not a bomb, then I'll increment the score inside it. So that's what is happening here. So I'll take index and I'll convert the character inside the cell, right? So by default it would be 0 because in the constructor we had given us that, right? And what it would do is it would yeah, so it would store the text and it would increment it, and I'll convert it back to a car, and I'll store it in the data, right? So that's increase value. And open cell. So open cell is what when the user clicks on open, it clicks the cell and opens it. This is the function that is called. So yeah, so status is changed to unlocked, right? And we'll return the character, like we'll return the data. So we'll look at it later. So why I have returned the data and stuff. And yeah, so basically when it's unlocked, uh, the when you're printing the data, what will happen? So I'll print out the data inside it, right? So that's the main thing. And trigger flag, so what this does, it's I'll show it, guys. Yeah, if the status is locked, so if the cell is locked, then I'll set the status as flagged. So if the status is flagged, then I'll set the status to locked. So that's what is happening. So I'll only call this trigger flag when the cell is either locked or it's flagged, right? So if it's flagged, it will be unflagged. In the sense, it will become locked, right? So it's a changing of status, right? And is unlocked. So this is just a bool statement. So it returns whether the cell is locked or unlocked, and is flagged returns if it's flagged or unflagged. And this is check for zero, check if bomb. So they do exactly what they say. So it checks for if the data is zero, then it returns true, and if the bomb's content is a bomb, then like the cell's content is a bomb, then it returns true. So that's basically it. Uh, so yeah, so that's basically cell implementation. We'll move on to the board implementation. So board is what makes up the game, right? So it's what constitute all the cell. So yeah, something like this. So the board contains all the cells, right? And for that, I have made use of double pointer. So I'll be dynamically allocating a 2D array for made up of cells. So that's what I'll be doing here. And I have a size integer to mention the size and the number of mines. So all these values will be set when the user gives the difficulty, right? So let me just open up the implementation. Yeah, so look at it. Board size and mines. So depending upon what the user has given for input, like if it's easy or medium or difficult, I'll be passing the board, like I'll be passing the parameters, and depending upon that, the size and mines will be set, and depending upon size and mines, the 2D array will be created, right? And yeah, so that's it. And cells open. So this is for the win condition. And if the number of cells opened is, I'll show you that. uh, okay, so I'll be doing that in the higher class, right? So this get cells opened will return the number of cells open. So cells opened is basically how much ever cells are unlocked will be stored here. And flag count is how much ever flags you have used. So if you have marked a cell as flag, then this flag count will get increased, and if you have unmarked it, then it will get decreased, right? And yeah, so bool board generated is when the first input is given, and you have generated the board. This board generated will get set to true. So from then on, the generation won't happen again. So that's why I have set a bool here. And bool bomb clicked is for the loose condition, right? So I have clicked the bomb, so the bomb clicked is true, which means that the game set is lost. And this is the coordinates for the bomb. So I've used x coordinates and y coordinates in the form of a vector, right? So yeah, that's it. And for the functions, so the board constructor, as you have seen, I set the default count. So flag count is mines, so you get the exact number of flags as you can get the mines, right? So when you use a flag, yeah, so it's the opposite. When you use a flag, the flag counts gets decremented, like decreased, and when you unmark a flag, it gets increased, right? So you can't use flags when your flag count is 0. So that's the main thing. Yeah, bomb clicked is false, and so that's the constructor. We move on to show board. So show board is basically called whenever you want to show the board, right? So I have made it so that uh, it shows the columns and rows, and it also prints the data inside it. So let me see. Yeah, so this is the cell, right? And that display cell. So display cell basically prints what's in it depending upon the status of the cell. So that's showboard. Unlock bombs. So unlock bombs will unlock all the bomb contained cells. So when I have clicked the bomb, I want the like all the places to show up. So at the end of the game, right, when the player has lost. So I have clicked the bomb, and now I'll call unlock bombs. So all the bombs will be unlocked, and when the show like print board is called, all the stars will show up. So that's why I've created unlock bombs. And then let's go to click cell, or let's go to generate board. Yeah, let's see, generate board. Okay, generate board. Okay, so generate board. See, rows and columns. So basically I'll be passing uh, yeah, what I'll be doing is I'll pass the first input of the player. So that input should be excluded when I am uh, planting the mines, right? So that's the main purpose of these parameters. And basically I'll just generate random x and y, right? uh, in the range of the size, and if it already exists, like if it's the coordinates of the current cell, then I'll just redo it, right? I'll get another temp x temp y, and if I have already placed the mine, then also I'll redo it, right? So for that I'll check this one. So each time I push set a bomb at a particular cell, I'll push in the coordinates into this x coord and y coord. So that's what I have used is vector, and I'll push it in. And the next time if I get the same value, I'll check inside x coord and y coord if that same value exists. So if it exists, I'll do redo it again and get another coordinate for setting the bomb. So that's how I have done this thing, right? And now that we have set the bomb, we have to set the values around the bomb, right? So that's this separate function, set values around mine, and for each mine I'll be calling the function. So let's go to the function. So this here row and column represents a mine, right? And what I have to do is I have to find each wait 1 second. Yeah, so I have to go around each surrounding cell and increment the value. That's what I have to do. So so I have set a min x, min y, max s, max y, and if it exits, like uh, for this cell there is no surrounding like there are less surrounding cells, right? There are only 3 surrounding cells. So for doing that, I'll be checking for the greater than 0 and less than size 0, right? Less than size values, right? When that is done, I'll be going through each surrounding cell. So say take this cell, I'll be going through each surrounding cell, and I'll be incrementing it. So that's what I have done. ARR ij increase value, right? We have seen increase value, so it just converts the char into int and increments it, and into char and pastes it, sets the data, right? So that's increase value where's generate board. Okay, so that's the end of generate board. As we had seen here, plant the mines and set the scores based on mines. So we have done this. So when board generation is done, the player can continue giving input, and yeah, so that's basically it. Next up, we have covered open adjacent cells. Uh, wait, no, we haven't. Wait, my bad. Set values around mine. So we have done that. Next one is open adjacent cells. So I'll get to that later. We'll get to mm, let's see, player select, player select. Yeah. So we'll get to okay, cool. We'll get to player select. So player select is what yeah, so basically we'll get the input from the player. So we'll get the row and column, and we'll get what the player has decided to do, either open or mark or unmark the cell, right? So this row and column represents the cell he wants to act on. And if the board has not been generated, so that's what this pull is for. If the board has not been generated and the player moves open, then I'll generate the board first and I'll set the board generator to true. So that's what is happening here. And after that, if the player move is mark, so if the player move is mark, then I'll just like if it's not, like if it's unlocked already, then I'll just give him an error, right? And if it's not unlocked, I'll just trigger the flag, right? Here is where I'll use flag count. So if the flag count is greater than 0, then I'll allow him to trigger the flag, and if it's not, then I'll give him an error. So it's simple, right? That's for mark. And then for the open, right? So I have now generated the board, right? And I'm going to open the cell. So I'll just call this one. So this click cell, this is a separate function. I'll, because it has its own like it's a big function itself, I have created a separate function for it. So click cell. So click cell is basically the row and column represents the cell that the player wants to open, right? So if the cell is flagged, then I'll give him an error. If it's unlocked, I'll give him an error. And if it's bomb, that means the, so that's where I'm using check bomb. So if it's bomb, that means the player has clicked on a bomb. So bomb clicked is true, and that's the end of it, right? And if it's a zero, so this is the special thing. So if it's not a zero, okay, so this is the, we'll finish a simple thing. So if the data is not a zero, then we will just open the cell and we'll increment the cells open and we'll just return true. So that's the end of it. If it's not like if it is zero, then we have to do a separate thing, right? We have to open adjacent cells and stuff. So for that, we'll be making use of a queue data structure. So the thing is, I did try doing this without the queue. So it would mean like opening adjacent cells as we are going through each cell, right? So it took a lot of time, and the compiler was not able to do it. It started crashing and stuff. So I started using queue. So basically, I'll explain where I'll be using queue. So if I, the thing is, if ARR, like if the current cell is 0, then I have to open adjacent cells, right? So that's this function. And yeah, so what this function does, it will push all the adjacent cells into this queue, right? X and y queue. So x queue is basic for x coordinates, y queue is for y coordinates. So I'll open this up. So yeah, I'll just okay, cool. Okay, open adjacent cells, and I have the row and column of the cell that we that cell, the cell that's at the center, right? So this row and column, and the queues and the vector, right? So the thing is, I want to push things in that are not like that are not already inside the queue. So that's why I've used a vector, because for in the case of queues, I won't be able to access the things that are uh, inside, right? So it will only give me the first one. So that's why I've used a vector for it. And I'll check if the cell is already in the queue using the vector, and if it's not there, then I'll push it into the queue. And okay, we'll go through this one. Open adjacent cells. So if the cell is a bomb, right, or if the cell is unlocked, then I'll just return, and I'll set the bool already present to false. So this bool is like basically it'll check inside the queues, like inside the vector, and if row and column already exists inside x vector y vector, then I'll set already present to true, and if that's the case, then I'll just return it, right? So by the end of this code, we'll know that the current cell is not present inside the queue, and what all we have to do is add this to the queue, right? The next step is to check if the current queue contains a zero. So if it does not contain a zero, then we'll just return to open it, right? But if it does contain a zero, then what we have to do, we have to open up the adjacent cells. So we have to open this one, this one, this one. Oh, my bad. We have to open this. So that's what we have to do, right? So yeah, we have to go through each surrounding cells and open them up. So that's what we'll be doing here. I'll be taking min x min y max s max x, and I'll be checking for the surrounding cells, right? And I'll just do open adjacent cells again. So this time we'll go through this open adjacent cells again, and if it's a bomb bar unlocked, and we'll just go back, and like if it's already present, we'll just skip it. If it's not present, we'll push it into the queue, and if it's not zero, we'll just return. If it's zero, we'll repeat the process again. So that's open adjacent cell. So it's a big big process, right? But all we are doing it is pushing all the cells that are uh, like supposed to be open into the queue, right? So we are pushing, when we clicked on this, we are pushing all these cells into the queue, right? And all we have now what we have to do is, until the queue is empty, we just have to open each of the cells up, right? So we'll open the cell, we'll pop it, open the cell, pop it. So do the same thing until the queues are empty. So now we'll know that we have opened up the gap, right? So yeah, so that's basically what open adjacent cells, and get cells open. So get cells open, we haven't done it. So we have done click cell and play select. So get cells opened is basically at uh, yeah, it returns the number of cells that are unlocked, right? Let's see here, right? It will return this integer, and get bomb click is get this bool value, right? And then we have a destructor, so pretty important one. We are destroying, like we are deleting the memory that was allocated dynamically, right? And the last class we are going through is the Minesweeper class, right? So this Minesweeper class is what controls all this stuff, right? Getting player input and showing the instructions and stuff. So that's what I've used this class for. It has the board, right? And basically each time we open the game, we'll dynamically allocate this board object, right? And we have the size, so size of the board, we have the difficulty, we have the game state, and the mines, number of mines. So I'll show you the Minesweeper implementation. So this is the constructor. So I'll be when I'm creating the Minesweeper game manager, I'll be showing the instruction. I'll ask for the difficulty, I'll create the board, and then I'll start playing. So I mean, the game set will be set to playing. So there are like some functions here. Instructions is basically will show you the show the player the rules, right? And up next is set difficulty. So set difficulty, what does it? It asks for asks between three values, so 1, 2, and 3, beginner, intermediate, expert, and depending upon that, it will set the difficulty enum, right? And yeah, so next step is create board. Yeah, so create board. So depending upon the value of difficulty, I'll be setting the size and mines of the, right, size and mines integer uh, using the macros. So I can change it up in the header, right? And Yeah, so that's basically it. And using the size and mines, I'll then create the board object. Next up is play. So play is the main driving function, right? uh, that's it. Okay, play is the main logic function, right? So it'll be looping player input while the game state is playing. So I'll show the board, I'll get the input until the game state is playing. And if it's lost, then I'll just unlock the bombs and show the board. If the player has won, I'll unlock the bombs again and show the bomb. Same thing. I'll just switch up the text, right? What else? Player input. So get input, right? So for each get input, the player has to give a row and a column. So that's what I have done here. So you can see that I have set the upper value depending upon the size, right? So I can give 1 to whatever the size is, and you can give two inputs for the operation. So one for open and two for flag or unflag. And if the I'll set the player like enum for player move as open or mark, and call the board's player select, uh, right? And if by the end of the move the player move is open and check win, so we'll look at check win, like check win, right? Here's check win. So we'll get for each, if the player move is open, then I'll get the number of cells open in the board. And if the number of cells is equal to the size minus the mines, then we'll know that the game like all the cells have been opened except the mines, so the game state is 1. And when that is done, we'll go back to here, right? This loop will end and game set is 1. Congratulations. So that's basically how I have implemented this. One thing we are missing is the utility implementation. So this is the char to int, simple conversion, right? And the random device generator, I have used the random header here, right? uh, so that's basically my implementation for Minesweeper console game. So try it out in the REPL. Thank you for watching.